Hey everyone, let's talk about presentations coming up. Before we do, I do have some guidance, some technical guidance on how exactly to put all this stuff together that you're generating. Some of you are just going to put into our ZFairs thing one file, as in you only want a poster, and that's it. And that's totally fine. If you don't feel like you want to make a paper that goes beyond what your poster tells us, then that's totally fine. That's all you have to submit. But some of you want to submit maybe a poster and a paper, or a poster and a paper and videos, or pictures, and more stuff all together. And this website, the BioSTLZ fairs that we're going to be importing our work into, only allows you to put one thing in per scholarship part. And you want your poster and paper to be together rather than separate files. So, how exactly do you do that for this application? Well, there's a couple ways we can do this. One is looking at how previous awards have been given, as in this is the award winner for Best Overall Engineering last year, and you can see that they made themselves a table of contents that linked portions of their project together. So they had a complete project and a link to list that out here, blueprints that linked over here, a video that they linked together, and the actual poster as a PowerPoint conclusion linked right here. I'm not saying you have to have all these files. I'm saying if you have lots of files, knowing that we can only import really one thing and that's it, this can be a stand-in for how you do that. So, how exactly do you make a table of contents with all these links together? Super duper simple. Here is a version that you can have if your project was the one we've been working with as an example all year long, the golf ball leachate on pond scum, the water fleas in the pond. Let's say you had a scientific paper and a poster and a video. Well, you can do exactly what they did and have a spot that says link here. Then you insert a hyperlink. Let's see, where's a good way to put a link? There we are. A link, and then you can find whatever item that you have here, or even easier, let's say we want to link this thing here. We copy the link to share it and put it in right there. Paste it in. There. Now it's a link to that poster, which you can do with the scientific paper instead. Now, there is a caveat here. If you were to share this, you do need to give it to me so I can share it, meaning that you already are probably going to share it with me, but when you look down here to general access, it should say anyone with the link can view it, and that might not be possible under our file sharing restrictions in Ford Zumwalt's Gmail and G Drive and stuff. So I should be part owner of your stuff and editor of your stuff so that I can host the file from my Google Drive and give you a link to put into your table of contents instead. That is the way to go. Now, you could also do what I've been telling a lot of you to do and have a poster with all the stuff that you ever want in the poster and maybe even have extra pages to it. That's totally fine, and combine it with a PDF merge of some kind. But if you have a video, that might not be the easiest. So if your primary document is the poster, and I'm using Julia's as an example here, already doing a great job at starting out with her poster. Let's say you had acknowledgments and references or a full paper or videos that you wanted to share and your poster is your primary document. You don't have very many other pieces to it. You can use a QR code to be able to share this with the people. Again, your document has to be partially owned by me in order to share it via a link with this QR code, but we can make that happen. If you'd like to put QR codes on your poster, very simple to do, don't worry. I will be happy to walk you through it. Just wanted to make you aware of your options, whether it's QR codes or merging the PDF with all your little pieces together or making a table of contents like this group did here. Those are your options for putting all of your files together into one mega file. Okay? Now let's actually talk about what you're actually here to learn, and that is how to present an academic research poster, because this is not like presentations that you stand in front of the classroom and give on your own. This is more like a gallery walk where you share at the same time as a bunch of other people are sharing. It will look an awful lot like this. That Aroa is here from 2025 demonstrating her project while others are demonstrating their project. And she has an audience member that is hearing her little spiel for a very short period of time and will then ask her questions about her project to either clarify some points or to critique some points or to ask for the implications of the project. You'll notice that Aroa is not standing here with like a billion things that she is reading directly off of. She is looking directly at the audience member and talking to them as if she were an expert in her project, because she is an expert in her project. So, this is going to take a little bit of practice for you to not have to read from the slides like you do with your other presentations. Instead, having a real conversation with your audience. But I have some methods on how you can structure your presentation so that it does give the audience as much information as you'd like to give them up front so that they feel more confident in the conversation you're about to have. So, this is a formula for a prototypical Expo presentation. This does not mean that this is the perfect Expo presentation. This is just a prototype, meaning it's a version that does the job. First, you have a hook that you try to grab their attention with, and you tell the audience exactly what the problem is and why it matters. You are trying to gather their attention, as in relate this with statistics that means a lot to them, or talk to them about maybe an instance that they have encountered with a family member who has a disease, like if you're talking about arthritis or coronary artery disease or something like that. Hey, everyone has a family member who suffers from that stuff, so it's very easy to say, do you have a family member that blah, blah, blah? Something like that. Or maybe you just talk about your rare genetic disorder and how awesome and challenging it is. Then you give the audience some background, just enough context to be able to follow through your findings, especially if you made or defined your own variables, such as root, mean, square, standard deviations of heart rate, or you set up a methods that you were very, very confident in this whole time, like a FRAP analysis of some kind. Hey, you guys did cool stuff. This is the time to talk about what you learned before you started the cool stuff and then how you created this project that looked into the cool stuff. Just to give us some context on what you did so we can follow along with what you found. The third section being the findings. We found that blah, blah, blah. Our solution to this problem is blah, blah, blah. If you have an engineering project, and then finally, just so what? Why we should care about your results and your design. What do your results mean? What could your design solve? Yada, yada. And that is it. 4 things that will encompass about 1 to 3 minutes. I would aim for 2 minutes. 1.5 is great too. That introduces your project so that it can be followed up by a real conversation with your audience. Not 10 minutes of rambling on and on like I do, 1 to 3 minutes at most just to get acquainted with the audience member and tell the audience member exactly what you did and what you found. That's it. Now, I will tell you that this is exceptionally easy if you have a good poster behind you. Notice that this is a AI generated poster that has our title that's very easy to read, has an introduction, has a discussion. The limitations and conclusions and future directions are actually separated, which might be more readable. Up to you if you want to do that. The methods are in bullet points, they're nice and easy to point out, and the results and raw data that they have are directly right in front and center. This is an adequate poster. It's not a great poster, it's an adequate poster. But notice if you add a few specific things that make your poster more of a visual aid rather than the entire project slapped on a piece of paper, notice that if we add more figures, like this line graph here, which, I mean, I would probably cut it off at the 50% mark here so that this looks like it's a more dramatic effect. And notice a figure that demonstrates the methods instead of walks the person through individual pointers. That's an option for you. Notice a rudimentary drawing made of the study organism, in this case Daphnia magna, which is just common water fleas. Notice that the organization of this poster allows the presenter to point things out and talk about them one by one rather than invites the person to read while they are talking. Nobody wants to read while they're being talked at. So use your poster as a way to pay specific attention for the audience of specific things, like the results that matter entirely, or like your methods if they are very specific to what you did and very unique, like the statistical analysis. This one has a one-way ANOVA, even if the results aren't statistically significant. This p-value is not statistically significant. Notice that this is set up in a way that you can show all that has happened in your project without being a bunch of words that you are invited to read along with the audience or inviting the audience member to read. That is why I continue to suggest that you should write a paper in addition to a poster, because a poster is a visual representation of the paper. But even without that, the point of your presentation is to not read the poster word for word. But you also don't want to be terribly vague. You don't want to rush through those 1 to 3 minutes just because I said stick to 1 to 3 minutes. If you have more to say more. So instead of being vague, like saying our results showed some effects on blah, 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 be specific and tell me what those results were. They dropped nearly 18% in the highest concentration group. And you can even list out what the highest concentration group is, or even compare it to the other concentration groups and show if there was a linearity to your results. The experiment didn't really work out. I know a lot of you are going to want to say this because you feel like your experiment didn't work the way that you intended. But just because you didn't get statistically significant results doesn't mean you didn't see any trend data or you didn't get something that's worth talking about. And instead, you can definitely say things like, our results were limited by sample size, but the trend was consistent with the prediction made at the beginning, or a hypothesis. You don't want to overgeneralize your results. Maybe the golf balls caused something. Cool, bro. Instead, say one possible explanation is blah, 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 the zinc leaching from the outer coating of the golf balls. Again, you don't want to read the poster or your paper word for word. You don't want to bore the person to death, but you also don't want to be too vague and miss out on the key findings that you actually had. after you have done your spiel, this person may have questions, and some of them may be challenging. Some of them may even be critical of your project. Maybe they're new ideas on how to test things that you didn't think of, or we didn't think of. Or maybe they are critical of your setup in some way, and you just could have tweaked it a little bit to find some different results. I would give you some pointers to this. You don't want to engage in an argument with them in any means. Their job is to be critical as an audience member. They may even have more expertise than you do. So the goal here is to acknowledge their critique as in show you understand what they're really asking and show what you understand what they're critiquing or trying to clarify. You want to give reason, as in you want to give the best explanation of what your data can say, even though their critiques might be accurate. And you want to redirect to what you actually found and measured in your study, because your data is true, regardless of whether or not it did the thing that you said it would or thought it would. Your data is reality. And so you can always bring it back to and redirect to our reality that you experience in lab. And you could say, hey, our sample size was smaller than it should have been. So maybe if we did this over and over and over again, we might expect different results. And that's okay. That's that's part of being in science. Being the expert doesn't mean you know every answer to every one of those questions. You need to show that you can think like a researcher instead of like this all knowing, omnipresent person. I think it was Neil deGrasse Tyson who said in one of the commercials for his masterclass the goal is to be enough of an expert that you are certain of some things, but are still willing to learn about all the things you don't know. Something along those lines. You are still willing to learn more past this project, even though some of you may never touch this project ever again. The goal is to portray this feeling that you learned something, but there is still learning to be done. That's the basics of putting together a presentation for yourself. Try to time yourself about 3 minutes in front of a mirror. Test it out on people nearby, whether it's your parents, your friends, your family, and see how you feel about your expertise in the background, in your results, in what your results mean, and discussion of your results. See if you can figure out what your project really is telling us and put it together in a very quick synopsis so that we can understand and ask questions. Let me know how I can help. We will have plenty of time to practice once these posters are printed, so let's get to it.